Hello everyone, welcome to my YouTube channel. In this video, I'll explain you one of the simplest yet powerful concept in data structures. What is it? It's Stackdeque. We'll understand what the Stackdeque means, how it works internally, and finally, I'll show you complete code implementation using Java NetBeans. So by the end of this video, you will get clear understand how Stack can be implemented using Deque. Before we talk about Stackdeque, let's quickly recall what a stack is. Stack is a linear data structure that follows LIFO principle, last in first out. It means the element that inserted last will be the first to be removed. So let's take a simple real life example to understand how a stack works. Imagine we start stacking books on a table. As you can see, there is 4 blue color books and 1 black book on a presentation. First, I place the first blue book on a table. Then I add another blue book on top of it. Next, I place the third blue book and then a fourth blue book on top. Finally, I place a black book at the very top of the stack. Now our stack has 5 books. Now I am going to remove the black book from this stack. The black book was the last one placed on the stack, and in a stack, the last item added is always the first one to be removed. That's the LIFO principle, last in, first out. So, when we remove a book from the stack, the black book comes off first because it was the last one placed. The other books stay in the same order. They'll only be removed when the books above them are taken off. This is exactly how a stack data structure behaves. You always push new items on top and pop them off from the same end. So you heard 2 words, name, push and pop. What are those words? Let's have some idea. So as you can see, in this presentation, there is a real stack and 4 elements. Now I am going to insert those elements into this stack. Firstly, I am going to insert the 4th element into this stack. So, this process we can call it push elements. Next, I am going to push the 10th element into this stack. Next, I am going to push the 8th element into this stack, and lastly, I am going to push the 5th element into this stack. So, as you can see, the 5th element is on top of this stack, so we can call it as top element. So now I am going to remove those elements from this stack. Now firstly I am going to remove the 5th element from this stack. This process we can call it pop elements. Nextly, the 8 become the top of this stack. Now I am going to remove the 8 from this stack, or push the 8 from the stack. So the 10 become the top of this stack. Now I am going to push the pop the 10th element from this stack. And finally the 4 become the top of this stack. And I am going to pop the 4 from this stack. Next, I am going to explain you about the core stack operations. Those are push, pop, we already talked about, and peek is empty and is full. Next, I will explain the push method of stack briefly with the use of array. So, as you can see, I created an array with the elements of 4, 10, 8 and 5. First, I am called the push methods, and you can see the 4 is inserted into the stack. I call the push method again, and you can see the 10 is inserted into the stack, and also the 10 is inserted into the array as the second element. And I call the push method again, and you can see 8 is pushed into the stack, and finally I call the push operation again, and you can see the 5 is inserted into the stack and the array. And next I will explain about the pop method with using the array. I'll call the pop method like stack.pop empty brackets, and you can see the 5 is pop out into the from the stack, and I'll call pop method again, and you can see 8 is pop out from the stack, and again, and you can see 10 is removed from the stack, and finally I call the pop operation again, and you can see 4 is pop out from the stack. What if we call pop operation again? We can see I'll call pop operation again, and you can see it gives an error. Next, we look into the peak operation. As you can see, there is a stack which is already full with elements, and I call the peak operation like stack.peak with empty brackets, and it returns 5. So the peak operation is used to return the top value of the stack. I call the peak operation again, and you can see it returns 5. Next, I'm looking to the is empty operation. So there is a array that defined as a stack with all the elements, and I call the is empty operation, and you can see it returns false because the stack is already full. And the second array is empty, you can see, and I call the is empty operation again, and you can see it returns 2 because it's correct, because the stack is empty. Next, we are looking to the is full operation. When we using is full operation, we have to assign a size of the stack. And you can see I assigning the max size of the array as 4, and you can see the first stack is already full with the 4 elements, and you can see it returns value of true. And the second array has 3 elements because and it is not full, and therefore when we call is full operation, it returns the value of false. Let's talk about another important structure called deque. Deque stands for double-ended queue. Deque allows insertion and deletion from both ends, the front end and the rear end. And also, deque can behave like both stack and queue depending on how you use them. Next, we'll talk about the types of deque. There are 2 types of deque. The first type is input restricted deque. As you can see, in this input restricted deque, we can do deletion from both ends, but the insertion can be done from only the one end. Next type is output restricted. In this deque, we can do insertion from both ends, but the deletion can be done from only one end. So next, I'll talk about core deque operation. The first operation I'll tell you about is insert front operation. When using this operation, I can insert elements from the front of the deque. Let's see. So I insert element 5 from the front of the deque. The indexes of front and rear become 0. Next, we look into insert rear operation. When using this operation, I can insert elements from the rear of the deque. Let's see. So I insert the 10th element from the rear of the deque. So the index of rear becomes 1. I use this operation again to insert another element to this deque. Let's see. When I insert another element using this operation, the index of rear becomes 2. Next, we look into delete front operation. When using this operation, we can delete elements from the front of the deque. So I delete the element 5 from the deque by using this operation. So as you can see, when I delete in the element 5, the index of front become 1. Next, we look into delete rear operation. When using this operation, I can delete elements from the deque from rear of the deque. So I delete the 8th element from the deck while using this operation. When I doing it, the index of rear becomes 1. Next, I'll tell you about the get front operation. When using this operation, we can take the value of element that stayed on front of the deck. Next operation I'll tell you about is get rear operation. When using this operation, we can take the value of the element that stayed rear of the deck. Now we understand stack and deck separately. Let's connect them. Stackdeque is simply a stack that uses deck internally for its operations. Instead of using arrays and lists for store elements, we use deque because it's fast and it supports constant time insertions and deletions from either ends. Now let's see how the Stackdeque works. So I created a deck that represents stack and I want to push elements into this stack using this deck. So I insert the first element into the deck from its front side and you can see the element is pushed into the stack. At this point, the indexes of front and rear become 0. And I insert another element and you can see this element is pushed into the stack and the index of rear becomes 1. And let's insert another element and you can see the index of rear becomes 2 and this element is pushed into the stack. And finally I enter another element and you can see the index of rear becomes 3 and this element is pushed into the stack. Now I want to show you how pop elements from the stack using deque. So first I remove the 8th element from this deck and you can see the rear becomes 2 and the element is pop out from the stack. Let's remove another element and you can see the rear becomes 1 and the element is pop out from the stack. Let's remove another. You can see the rear becomes 0 and the element is pop out from the stack. Let's remove the 4th element from this stack and now you can see the front and rear becomes null. Now I am going to give you the code explanation on Stackdeque using Java NetBeans. In this code I am going to create stack using deque. First, we import the necessary Java tools, the deque, the interface, the general contract, and the highly efficient ArrayDeque class, the specified implementation. And we also need empty stack exception for error handling. And next, I defined the generic class that will act like a stack. I using the type parameter so it can hold any type of object. Next, I defined the line. I declared our internal data structure, a private final deque object named deque implemented using ArrayDeque. This is the engine that does all the works. Now I implemented the push method. It's the standard stack operation, but watch how it uses the deque. Next, I defined the key mapping. We mapped push to the deque's addLast method. So we are adding the new element to the end of the deque. This ensures that element 8 remains at the visual top of our list structure. Next, I am using the print statement to show the viewer what was added and the stack's current state immediately. So next, I am defining the pop method which removes and returns the LIFO element. Next, I use the condition. So I first check if the deque is empty. If it is, I throw an empty stack exception to make the stack implementation safe and robust. Next, I implement the LIFO mapping to enforce last in first out. So I use the deque's remove last method. Since I added the last element to the end, removing from the end ensures that the last element in is the first element out. Next, I define the peek method which looks at the top element without removing it. To see the element at the visual top, the element 8, I use the deque's getFirst method. The simple check to see if the stack has any elements, it directly uses the deques built-in isEmpty method. Now I am going to explain the main method. This is the entry point where Java execution begins. So firstly, we initiate a new object of our Stackdeque class so it ready to hold integer values. This is the push sequence. We are adding the element 8, 10, 5, 4. Because we are using addLast, the element 4 is the last in element and the element 8 is the visual top. Next we call peak, which should return 8, the element at the visual top. This is the pop sequence. We call pop 4 times in the console and you will see the element removed in LIFO order. Firstly 4, then 5, then 10 and then 8. This is the visual proof of our implementation. This print the final state which should be true after the 4 pops. And last, this demonstrates our exception handling. We wrap the extra pop call in a try catch block. This catch block executes, proving that our code gracefully handles the error instead of crashing. So that's the code explanation. Now I am going to execute the code by using the debugger of Java NetBeans, so you can get a clear idea how the stack is going to create using deque. That concludes our deep dive. We started by defining the stack and its core LIFO principle, then we explored the versatility of deque, and then we proved that the most efficient and modern implementation, the Stackdeque, is achieved by cleverly mapping the stacks method onto the deques functionalities. So, if you think this video is clear and helpful for you, please hit the like button and subscribe for more programming essentials. Thank you.